Okay, so today with our synthetic division, we're going to work through this note sheet here. The first thing it asks us to do, though, is it gave us this problem, x to the fourth minus 7x squared plus 9x minus 10, and then divided it by x minus 2. So we went ahead and did that using long division, which the techniques we practiced yesterday. But it's going to be helpful to look at this as we go through the synthetic division. Okay, now synthetic division you should have done at some point in the past. It's nicer. It's a lot easier. Makes it very nice. So with this, kind of the big thing that we're going to do is with synthetic division, we're not going to use any x's at all. We're just going to use numbers. And the numbers are just going to represent the coefficients. So with this, what we'll do is here we see that we're dividing by x minus 2, correct? So what you want to, for this factor, think about the associated value, I guess, which would be positive 2, correct? So in this case, if this is x minus c, c itself would be the number 2. Okay, so synthetic division, one thing important to realize is it only works when dividing by x minus c, or x plus c. But if you had a 2 in front of the x, it doesn't work. If you have an x squared, it doesn't work. It has to be x minus a number or x plus a number. So what we're going to do with this is, here's our divisor is x minus 2. So c in this case would be the number 2. And that's what's going to go up here in the little box in the corner. Right? So that value there, that's going to be your c value. So that's, again, it's going to be the opposite of what you see in the factor, which is not that, if you think about the factor theorem, kind of an instance of that same thing happening. Now, we mentioned that with the long division, it was nice to put a spacer here for the 0x cubed. It helped things line up better. With synthetic division, you have to put a spacer. If you don't put the 0 there, it will be wrong. It just won't work out. So what we're going to do is we're going to look at our dividend. It's in standard form. And we're just looking at the coefficients. So the coefficient on x to the fourth is 1. The coefficient on x cubed, there's not 1, so that's going to be 0. The coefficient on x squared is negative 7. And then 9. And then negative 10. Then we draw like a tally bar down here. We're going to tally up. So we'll have numbers in here, and then we'll have numbers down here. So let's see what happens with this. And the sort of the process here is, I always think we're going to add down, multiply over. Okay, so add down, multiply over. So what we'll do, and a lot of people will show this with like an arrow here, but to start off, this first coefficient just drops all the way underneath the bar here. So it goes all the way down. Or you could think of it as you added it to 0 if you wanted to, or some people would, like I said, draw an arrow. It's fine. Now, to get the next number, which will go right here, we're going to do 2 times 1, which is 2. We're going to place it underneath the 0. Now, because we did this because the divisor was actually x minus 2, and we put a positive 2 here for c, we get to add with synthetic division. We don't have to subtract. So, which is a good thing. So 0 plus 2 is 2. We'll put that down here. Now, to get the next number here, we'll do 2 times 2, which is 4. That'll go right there. Negative 7 plus 4 is negative 3. You might notice 1, 2, negative 3. Right? That bottom row is giving us the quotient plus the remainder. 2 times negative 3 is negative 6, which gives us 3. And then 2 times 3 is 6, which gives us negative 4. So if you look now at those coefficients on the bottom, our remainder was negative 4. Right? The coefficients were 1, 2, negative 3, 3. So what you'll find is always this bottom row is this last number here. That will be our remainder. We divided by a linear factor, so we know the remainder has to be a constant, right? Because it has to be degree 0. And then right here, this will represent the coefficients of the quotient. That will be the quotient. And what happens is, anytime you divide a fourth degree, the quotient will be third degree. Right? If you divide a seventh degree, the quotient will be sixth degree. It just takes one away from it. So this is going to be cubed, squared, x, and this will just be a constant. So what this shows us here is that q of x will be x cubed plus 2x squared minus 3x plus 3, and the remainder of x is equal to 4. Now, if you had a different, if it told you to write it in some different format, you could, but that would be how that would go. Yes?
-4.
It is -4. Oh, goodness gracious. But that makes it agree, so that's a good thing. Yeah, it is -4. Does that seem to make sense here? Do you guys remember that? Or does everybody remember that process? Vaguely? Okay, good. Okay, so for our next example here, we have x to the fourth minus 6x cubed minus 40x plus 33 divided by x minus 7. So again, this is our x minus c, so c will actually be positive 7, which is kind of good news. You choose a positive number. So put it up here in the corner. We're going to list the coefficients. Notice there's no squared term, right? If you need to, a 0 is a placeholder, right? So we're going to do 1, -6, 0, -40, 33. I think the numbers got too big here. Yeah. So 1 drops down. 7 times 1 is 7. Add those and we get 1 again. 7 times 7 is 7. Add those, you get 7. And this will give us 49, which will give us 9. And this will give us 63, which is 96. Okay. So that's the remainder. Right? And then our quotient would be x cubed plus x squared plus 7x plus 9. And if you are asked for the quotient, you do need to put the x's back in there. You can't just, forget about them. Does that work for everybody? Okay. Now there's another property we didn't talk about yet called the remainder property. What it says is if you take 7 and you plug it into this function, your answer is going to be 96. Kind of a cool thing. Again, it's called the remainder theorem. We don't use it a ton, mostly because if you have to multiply big numbers, you just type them in your calculator. But it's where the factor theorem comes from. It says that, in this case, if, so let's see, p of x divided by d of x has a remainder, well, yeah, that's a little bit weird. So if you have p of x divided by x minus c, right, the factor, has a remainder r of x, and p of c will also be equal to that remainder. So whatever the remainder is also what you would get if you plug that number in there. That's why we looked at with the factor theorem yesterday. If you put your c in and you get 0, it means it's going to be a factor because it's a 0. Basically, c is a 0, x minus c is a factor. Sort of our thing going on there. And do be careful on this one. It asks you to write the answer a certain way. It wanted quotient times divisor. Remember the divisor is x minus 7. And then plus 96 for the remainder. So that way, if you had to check it by hand, you could multiply these out, add 96, and you should get back to p of x, the polynomial that was divided, to start this whole thing off. So let's try the next one on here and just make sure that we're getting that. So okay, and then here's one more, again from the worksheet. So kind of looking at them, I always just, really a good habit, I guess. I should probably point it out, but like I'm looking at it saying, okay, am I in standard form? I am. Is there any terms missing where I'm going to have to put zeros in? I don't. But if you can always get in the habit of looking at the problem before you just jump right in, especially as things get more complicated, it can really save yourself a lot of work. Maybe just a slight adjustment before you start the process might make things much easier. I think what we're doing in calculus right now is like that. So, in the box is a 3, right? That corresponds to the factor, or to the divisor x minus 3, so put a 3 in the box. And then 2, negative 11, 15, 6, negative 18. Make sure I've got all the signs correct, and we'll go ahead and 2 will drop down, and then 6, negative 5, negative 15. That looks like it might be a problem, but it's not. It just means our quotient's going to have a missing term, if you want to think of it that way. 0, 6, 18, 0. Now that's something that's pretty significant, is here we have a remainder of 0. Right? So that's our remainder. And then our quotient, this was 4th degree, so our quotient will be 3rd degree. So it's going to be 2x cubed minus 5x squared. I don't put plus 0x, that's kind of redundant, and I just say plus 6 would be our quotient. Now, the real power with this is when we have that remainder 0, it actually started to factor this. So if we think back, we had p of x equals d of x, or I think we usually say q of x first, but they don't matter. Q of x times d of x plus r of x. Right? That was the way we like to write our answer out, one of the two ways. So what this tells us is if we take 2x to the 4th minus 11x cubed plus 15x squared plus 6x minus 18, that will be equal to the quotient 2x cubed minus 5x squared plus 6 times the divisor, which was x minus 3, plus 0 because there's no remainder, right? So the remainder is not there. So we can see whenever the remainder is 0, it actually, the synthetic division process serves to actually factor the polynomial. Okay, so we took a 4th degree, we factored it to be a 3rd degree times a linear. Now, a lot of times this will be factorable by methods we already know. This is not one of those times. This probably doesn't factor at all. Next time we're together, we'll look at ways to determine, what we'll do is we'll look like at this thing now and see if we can divide it by something. So that's the idea. And since we have synthetic division, which is pretty quick compared to long division, we can test some different things. Or we could go back and use our factor theorem and see if, maybe if I think that that x minus 2 is a factor of this, right? If x minus 2 would be a factor of this, let's just say, if I plug 2 in here and I get 0, then it assures me that it is, then I can actually go ahead and do the division.